AECL is in the nuclear business. We design nuclear reactors, we build nuclear reactors, we operate the NRU, and so we need to meet very stringent standards. The standards for nuclear components in Canada are very strict, and so AECL has the capability, has the certification to be able to build nuclear components and to do repairs as we're doing on the NRU. We are meeting those codes and standards, and so we can verify that all of the work is done to that standard to prove to ourselves first, and then also to the regulator that the vessel meets all of its design requirements. The first thing you've got to realize is that the repair process really started months ago. Started with the selection of the repair technique as being weld buildup, started with the design and the building and the testing of the equipment, of the welding equipment to be able to do this kind of a remote weld buildup repair, and then all of the training and qualification of the staff that were going to be involved in the repair process. Then the welders complete their qualification and practice in order to verify that they can do a reliable weld, and every time. And then we take the tooling to the reactor. We actually do another practice weld in the reactor next to the vessel wall as a final confirmation, and then we go and do the repair on the vessel wall. And the other thing we do is that we go by afterwards and we do something called laser profilometry. We actually use a laser beam to measure the amount that the vessel wall has moved as a result of the welding process. Then we go back and we compare that to the original stress analysis to verify that in fact the stress that the vessel has been subjected to from the repair is the same as the stresses that were calculated before we did the repair. So it is a very complex process and a lot of steps, and we come out of that with the proof that we have done a quality repair. And so as we move along, we're using more complex repair techniques. We've gone from vertical welding directly onto the wall of the vessel to areas that are thin, and there we're installing what we call a backing plate that's put onto the wall before we do the build-up weld in order to make sure there's enough material there for the build-up weld. And then when we're finished here, we have 2 sites left. And those 2 sites are the ones that are the most challenging in terms of the largest sites requiring the most extensive repair. They will require the most complex models. They will require the most extensive repair techniques. And so as we do the repair on the existing sites, we are mocking up and practicing the repair on the more complex sites. I might just add that in parallel with doing the final repairs, we've moved away from some regions of the vessel. And so in those regions, we are cleaning them and returning them to condition to be ready for operation. We will actually begin to reassemble the reactor vessel in the areas where we're not still doing repair work. So in that way, we're integrating the repair with the processes and getting ready for restart or returning the reactor to service. And so we can save time and move ahead with some of these other tasks.